Alright guys, welcome back. We're going to be talking about quadratic functions, more specifically projectile motion. So our learning targets for today are to use quadratic equations to model the height of a projectile over time, as well as determine the projectile's maximum height, time to reach it, and total flight time. The formula that we're going to be using is going to be in the unit measure of feet. So let's get started. The projectile motion formula is h of t equals gt squared plus vt plus s. Now, I know that can be intimidating for some people. There's a lot of letters there, right? But each of them stands for something, and it's actually pretty manageable once we know what everything stands for. So, T stands for time. H stands for height. V stands for velocity. S stands for starting height. And G stands for gravity. Okay, so on this this note sheet, we're going to be assuming that G is always going to be -16. So I added that little note in there because gravity is constant on Earth. For every problem on these notes, G is always going to be -16. That doesn't mean it's always going to be -16 in other problems you see, but for this this document, we're going to be using -16 for G. Okay, so we're looking at the parts, we're looking at the trajectory of a cannonball in this example. And really it's just for us to kind of wrap our brains around how projectile motion works. So when we look at this image, a common mistake that people will make is they'll look at the image and assume that they're looking at cannonball's flight over distance. So it's not distance being measured on the x-axis, it's time. So it's very important that we kind of understand the difference. What's being shown on this coordinate plane is the maximum height a cannonball would reach over time and the total flight time, right? So when we look at this, let's start by labeling our parts, okay? So we have a cannonball and we're looking at the initial height. So the initial height of the cannonball is at 0 feet, right? So we're going to go and write that in, 0 feet. And the maximum height is reached at 150 feet. Now, I'm assuming that you guys are familiar, but if not, what we just labeled was actually called the vertex. This is the vertex. Now, this is a downward opening vertex, so this could also be called a maximum, right? Which kind of fits perfect because it's also called the maximum height of a projectile. So our vertex would be the coordinates x and then y, so 10 and then 150. The zeros, or x-intercepts, are, we have one at the initial launching point, so there's 0, 0, and the other one is here at 20, 0. Now that we have all of our things labeled, let's actually label this. These are our x-intercepts. I want us to think about it. What does the vertex represent in the context of projectile motion? So when we're looking at the image in front of us, the vertex represents the time it takes for the object to reach its maximum height. So the vertex represents the maximum height, the max height, the max height, and the time it takes to reach it. What do the x-intercepts represent in the context of this problem? So when we look at our graph and we imagine a cannonball getting launched into the sky and then hitting the ground, right? It travels, it goes all the way up, and then gravity starts to bring it down, right? So we would call that the starting point, the launch point. So in this particular problem, it's talking about the launch point and the landing point. Or we could say the total flight time, right? From the time that it gets launched to the time it lands. So the x-intercept represent the total flight time. Now, really great question here. Where have you seen parabolic motion in your life, in real life? The first example that comes to my mind is, sports. And I think about like a football being tracked in the air, or maybe even like a golf ball, right? If you guys have ever watched golf, I don't know. I've seen a couple golf tournaments and seeing that little arc being traced with the live ball, pretty cool because I know that's a parabola. Another one that comes to mind is a really popular phone game. Maybe not so popular anymore, but Angry Birds. Angry Birds. So if you guys recall Angry Birds, there used to be these birds that you would pull back on a slingshot and you'd launch them at towers with like little pigs and you get high scores. That game was awesome. But Angry Birds is another example. Okay, now that we've kind of got those parts dialed in, let's work through some examples. Example 1. The following equation represents a cannonball's trajectory. Given the formula h of t equals negative 16t squared plus 48t plus 5. We got to find the time to the maximum height and the maximum height. Now, from what we just talked about, we know that these guys are talking about the vertex, right? They're talking about the vertex. And from standard form, if you guys remember, standard form is ax squared plus bx plus c, right? So this is kind of in that same format. The variables are a little bit different, but it's still a quadratic in standard form. To find the vertex from standard form, we use the formula negative b over 2a, and then we plug it in, or we use the function of negative b over 2a, right? That just means plug it in. So when we're talking about vertex, this is our time, right? The time to the height, time, and this is our max height. Okay. So it's our time to max height and then our maximum height. So we need to find both of them. So that said, we're going to identify our A, B, and our C, our coefficients. So A equals negative 16, B equals 48, and C equals 5. Great. So now we're just going to plug in and then we're going to go. So we get negative 48 divided by 2 times negative 16. We get negative 48 divided by negative 32. So that's about, well, it's 1.5. Positive 1.5. So this cannonball will reach its maximum height at 1.5 seconds. Nice. Now that I know that the maximum height will be reached at 1.5 seconds, I know now what t is. That is my t value. Okay, so my t value is 1.5 time. If I want to find the height at 1.5 seconds, I need to take that 1.5 and substitute it in everywhere I see a t. And that would give me my height at that time. So it's going to be h of 1.5, right? That's the time we're looking for, equals negative 16 times 1.5 squared plus 48 times 1.5 plus 5. So this equals 1.5 squared is 2.25. And then that's going to get multiplied times negative 16. And then 48 times 1.5 is 72. And we got plus 5. And then we got negative 16 times 2.25. That's negative 36 plus 72 plus 5. So all of that equals 41. So the maximum height of the cannonball is 41 feet. Nice. All right. So example 1 down. We're going to do another one together, and then I'm going to give you an opportunity to try the third example. So here we go. Example 2. Same type of problem. So we're not going to rewrite the equations that we need to solve it. We're just going to start solving it. So again, we're looking for the vertex, and we know the vertex is negative b over 2a. And then we're going to define the function of that, which is just means plug it in. So we're going to get negative 50, that's b, over 2 times a. So here we go. This is negative 50 over negative 32. So that is about 1.6. So it's an ugly decimal, but it's about 1.6. So we're going to round to the nearest tenth. It's about 1.6. I'm going to take that time and substitute it into the original equation. So for t, it's going to be 1.6 seconds. So it's going to be h of 1.6 equals negative 16 times 1.6 squared plus 50 times 1.6 plus 25. So this is going to be equal to negative 16 times 1.6 squared is about 2.4 plus 50 times 1.6 is 78.1. And then we got plus 25. All right. Negative 16 times 2.4 is about negative 39.1 if we round to the nearest tenth. And then we're going to add 78.1 and 25. All of those add up to equal 64. So the maximum height is about 64 feet. Beautiful. All right, moving on. This is where you guys get to kind of show what you guys know on the you try portion. All right, this is your guys' time to shine. So the you try. I want you guys to take a moment and pause the video right now and try this one on your own. Go ahead. All right. I hope you guys paused it and were able to solve through it. Let's work through it together so you can check your work. So it is similar to the last problem that we just, the last two problems that we just did. So we're going to be finding the vertex, right? So it's going to be negative 64 over 2 times a, which is negative 16. So negative 64 over negative 32. So this is going to result in a positive 2. So the time to the maximum height is 2 seconds. All right. Now that I know the maximum height is 2 seconds, I'm going to take that value, 2, and I'm going to substitute it into the original equation. So it's going to be h2 equals negative 16 times 2 squared plus 64 times 2 plus 12. So that's equal to negative 16 times 4 plus 64 times 2 is 128 plus 12. Negative 16 times 4 is negative 64 plus 128 plus 12. That equals 76. So if you got your maximum height is 76 feet, you did it absolutely perfect. Great job. So we're going to be moving on to a new type of problem where we're going to be finding the trajectory equations. So in the previous three examples, we were given the equations for the trajectory of the projectiles. But on this one, we're going to have to write our own equation as well as finding the maximum height, and then another additional step. We're going to be finding when the ball hits the ground, or whatever the object is hits the ground. Okay, so I'll go ahead and write all the formulas that we need to be able to solve this type of problem. The first thing we need to remember is the original formula, right? So the original formula for projectile motion is h of t equals gt, so that's gravity, that's our constant, -16, right? Plus vt, that's our velocity, plus s, our starting height. So we know we're going to need to remember that formula. The other thing we're going to need is the vertex. So the vertex is negative b over 2a, and then the function of negative b over 2a, so that just means plug it in, if you guys remember. And then the last one we're going to need to find the when the ball hits the ground is the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So quite a few formulas to be able to solve all these parts, but two of them we know pretty well. In the quadratic formula, it's just a matter of substituting in values and then simplifying. So here we go. Let's get started. Let's start with the trajectory equation. So our trajectory equation is going to start off with h of t equals -16t squared plus the velocity. So remember, velocity is distance, the distance that something travels over time. So it's 32 feet per second. So in this case, velocity is 32. And our starting height is 8. Okay. So now we have our trajectory equation. Great. Now we can start working through the other parts. So we're going to find our vertex. So b is 32, so it's going to be -32 over 2 times a, which is -16. So that's -32 over -32, which equals +1. Now, that is not our maximum height. That is the time it takes to reach the maximum height. So in order to find the maximum height, we need to take that one and substitute it into the equation. So it's going to be h of 1 equals -16 times 1 squared plus 32 times 1 plus 8. So this is really going to be -16 plus 32 plus 8. So, that is just 21. Oh, not 21. Sorry, calculated that. It's 24. 24. So the maximum height is 24 feet. Great. Now we're going to be using the quadratic formula. So we already kind of know what standard form is, but it might be helpful for us to list out those terms. So a equals -16. I'm getting that from here. -16. B equals 32. And C equals 8. All right, so I'm going to take those values, I'm going to plug them into the quadratic formula, and we're going to solve it. So we get -32 plus or minus the square root of 32 squared minus 4 times a, which is -16, times c, which is 8, all divided by 2 times a, 2 times -16. All right. 32 squared is 1,024. And then 4 times -4 times -16 is going to be a positive number. So we're going to get 4 times 16 times 8. That's 512. So remember, all of this is underneath the radical. 1,024 plus 512 is 1,536. Okay. So if I rewrite this, I get negative 32 plus or minus the square root of 1,536, all divided by negative 32. Okay. From here, I need to find out exactly what the square root of 1,536 is. So I'm going to take the square root of that, and it's going to be about 39.2. So this is about 39.2. So I have two different versions of this problem. I have a negative version and a positive version, just so you guys know. Okay, that's what this means. So I'm going to zoom in right here. We get negative 32 plus 39.2 divided by negative 32. And then I have negative 32 minus 39.2 divided by negative 32. Now, there's no real need to work through the plus version of this problem because of in the end, it's going to end up being a negative number. Now, that's an issue because we can't measure time negatively, right? There's no such thing as going back in time, at least not that we're aware of. So this is going to give us negative. This is going to give us a negative, right? A positive divided by is a negative. So this is a no-go. We can't use the positive version. No-go, because it gives us negative time. It's about negative 0. Let's see, 7.2 divided by 32 is 0.2 seconds. So it's negative 0.2 seconds. But we can't have negative time. So we're going to go with the one that's going to give us a positive time. We can't say that the ball landed negative 2.2 seconds ago. That doesn't make any sense. So we're going to go with the negative version of this problem. So we get 32 and 39.2. That is 71.2 divided by, it's negative. A negative divided by negative is going to result in a positive. So this one's actually going to be a good answer. And this is about 2.2 seconds. All right. Now, that was a lot of work, and the quadratic formula took a lot more space this time. And so if it was a little cramped on your guys' sheet, I apologize, but we won't have to do as much formulas on the next one, since we already have our formulas here. I'm actually going to put a little cloud around this because this is important, these formulas, because we're going to use these same formulas for the next two examples. Okay, so here we go. So we don't have to rewrite those formulas. We can go straight into finding our trajectory equation. So reading the question, we have a trash ball, and it's being flicked from a table 5 feet above the ground. So that's our starting height with a velocity of 32 feet per second. Great. So we know it's going to start off as h of t equals negative 16t squared. Our velocity was 32, and our initial height was 5. Sweet. So let's move on. So we're going to find our maximum height. So that's our vertex, which is going to be negative b over 2a, and then plug it in. So it's going to be negative 32 over 2 times negative 16. So that's negative 32 over negative 32, which is positive 1. Again, that is not our max height. That is the time it takes to reach the max height. So we're going to substitute that value in. So it's going to be h of 1 equals negative 16 times 1 squared plus 32 times 1 plus 5. So that's going to be negative 16 plus 32 plus 5. So h of 1 equals 21. So the maximum height is 21 feet. Great. So we have way more room this time because we didn't have to write all those formulas. So here we go. We're going to just plug straight into the quadratic formula. We got negative b, so negative 32, plus or minus the square root of 32 squared minus 4 times a, which is negative 16, times c, which is 5. All right, all divided by negative, 2 times negative 16. It's going to skip a step there. Okay, so 32 squared. 32 squared is 1,024. And then again, we have a double, two negatives getting multiplied here. It's going to result in a positive. So we got 4 times 16 times 5. That's 320. So add those together, we get the square root of 1,344, which is approximately 1,344. The square root of that is 36.7. 36.7. Okay, so we got negative 32 plus or minus 36.7 divided by negative 32. Remember, the positive version of this problem is going to give us negative time, so there's no need to, go down that rabbit hole. Instead, we're just going to do the negative version of this problem. So it's going to be negative 32 minus 36.7 divided by negative 32. So when we combine those two, we get 32 and 36.7 is negative 68.7 divided by negative 32, which is going to result in a positive number, about 2.1 if we round to the nearest tenth. So this is 2.1 seconds. Sweet. All right, we've come to the last section of our notes, and this is time for you to show what you know. So right now, I want you guys to go ahead and pause the video and give it a shot. All right, I hope you guys paused it and you guys were able to work through it, and you guys are just going to, be able to watch to the very end and see if you guys got it right. So let's work through it. A basketball is shot from 6 feet above the ground with initial velocity of 48 feet per second. So let's write our trajectory equation. It's going to be h of t equals negative 16t squared plus 48, that's our velocity, t, plus our starting height is 6. All right, now to find the maximum height. It's going to be negative b, so negative 48 over 2 times a, which is negative 16. So we get negative 48 over negative 32, and 48 divided by 32 is 1.5. So this again is not our maximum height, it is our time to the max height, right? So we're going to take that 1.5 and we're going to plug it in. So we're going to get h of 1.5 equals negative 16 times 1.5 squared plus 48 times 1.5 plus 6. Okay, so we get 1.5 squared is 2.25. So we get negative 16 times 2.25. And then 48 times 1.5 is 72. So plus 72 plus 6. All right, negative 16 times 2.25 is negative 36 plus 72 plus 6. Those all combine to equal 42. So our maximum height is 42 feet. Hopefully you got that. Now onto our quadratic formula to find when the ball hits the ground. All right, so it's going to be negative b, so it's going to be negative 48 plus or minus the square root of 48 squared minus 4 times a, which is negative 16, times c, which is 6. All divided by 2 times a, which is negative 16. All right, 48 squared is 2,304. And again, we have a positive because we have two negatives multiplying. So 4 times 16 times 6 is 384. And those two add together to equal the square root of 2,688. And we're going to find the square root of that. So 2,688, the square root of that is 51.8. It's about 51.8. Okay, so we get negative 48 plus or minus 51.8 all over negative 32. Remember, the positive version is going to give us a negative. So we can avoid that one. So we're doing the negative version. So we get negative 48 minus 51.8. And then we got negative 32. So we got 41 minus 50, I'm sorry, 48 minus 51.8. We get 99.8. So this equals 99.8 negative divided by negative 32. We get 3.1 seconds. So the answer is 3.1 seconds. Alrighty, guys. I hope you guys all learned something today. I really do appreciate you guys watching the video. See you next time.